Hi everyone, my name is Dr. Teresa Chimampam and welcome to Lecture 2 on Basic Inorganic Chemistry. In Lecture 1, we covered science. We discussed what science is all about, scientific methods, importance of chemistry. We discussed about matter and the different states of matter. We discussed about energy. We discussed scientific notations, mass and weight. We also talked about precision and accuracy and significant figures. So, for today's lecture, we will be covering density and specific gravity. So, at the end of today's lecture, you will be able to define density and specific gravity. You will be able to identify units that are used for density, and you will learn density calculations. So, what is density? Density shows us how tightly packed a certain amount of space is. Like you can see here, it is tightly packed, so it has high density. This is not tightly packed, it has medium density, and this has low density. So density shows us how tightly packed a certain amount of space is. When more mass is packed into an amount of space, as you can see here, we say that it is more dense than if less mass were packed into the same amount of space. As you can see here, this has low density while this has high density. Heavy liquids will always occupy greater volume, and heavier liquids will always settle at the bottom, and density varies with temperature. So it is important to know that heavy liquids will always occupy greater volume, and heavier liquids will always settle at the bottom. It is also important to note that density varies with temperature. So if we want to calculate density, we use the formula density equal to mass divided by volume. With this formula, we can calculate mass and we can also calculate volume. So mass is equal to density multiplied by volume. This is derived by simply doing cross multiplication here, and you will have mass is equal to density times volume. And also we can calculate volume using the formula volume equal to mass divided by density. All these are derived from the first formula for density. So we derive this mass formula from the density formula, and we derived the volume formula from the density formula as well. So the unit of density is gram per milliliter or gram per cm cube. And it is important to note that 1 milliliter is equal to 1 cm cube. Right, so let's look at some density calculations. If the mass of a metal is 34 grams and volume is 4.65 cm cube, calculate the density in gram per cm cube. So we start by writing down the formula for density. Density is equal to mass divided by volume. And we then put in the values in the formula. The mass is given as 34 grams. We put it here, and we put the value of volume that is given, which is 4.65 cm cube. We put it for volume. So if we divide 34 by 4.65, we will get 7.32. So because we have gram here and cm cube here, the unit would then be 7.32 gram per cm cube. How to calculate mass? The density of steel is 8.05 gram per cm cube. What is the mass of 40 milliliter of steel? To solve this problem, you can see that the unit of volume is in mil, while the density is in gram per cm cube. So the volume needs to be in cm cube. Remember that 1 milliliter is equal to 1 cm cube. So what it means then is that 40 milliliter of steel is equal to 40 cm cube of steel. So now that the volume is in cm cube and the density is in gram per cm cube, we are good to go. So you start by writing down the formula for density, which is equal to mass divided by volume. And if you do cross multiplication here, you will get that mass is equal to density multiplied by volume. So now that we have the formula for mass, we can then put in the values that we are given in the problem. So putting in these values in this formula here, we will have that density is 8.05 gram per cm cube. I put it in this form so that units can cancel out, and you put in the value for volume, which is 40 cm cube. So you can see that cm cube here cancels this cm cube here. And then if you multiply 8.05 by 40, you will get 322. Because gram is the only unit left, the final unit would then be in gram. So this is a way of knowing what your final unit will be. If you leave all the units, some will cancel out, and the one that is remaining will be the final unit. So the answer to this problem is 322 gram. Right. How to calculate volume? Calculate the volume in milliliter of 48 gram of acetone if the density is 0.79 gram per milliliter at room temperature. So we start with the formula for density. Density is equal to mass divided by volume. But because we are asked to calculate volume, we need to make this volume the subject of the formula. So if we do cross multiplication, we will get that mass is equal to density multiplied by volume, simply by doing cross multiplication here. But we still want this volume to be the subject of the formula. And to do this, we divide both sides of the equation by density. So if we do that, this density will cancel this density, and volume is then equal to mass divided by density. So once we have this, we can then put in the values that we are given in the formula. So mass is 48 gram given here. We put it for mass, and we put the value for density, which is given as 0.79 gram per milliliter. And we notice that gram here will cancel this gram here. And if you divide 48 by 0.79, you will get 60.8. And the only unit left is per milliliter. So then the final unit will be in milliliter. So this is how to get your final unit. If you leave all the units, some of them will cancel out, and the ones that are left will then be the final unit. So the answer to this problem is 60.8 milliliter. So you can practice these problems just to make sure that you have understood how to do density calculations, how to calculate density, and how to calculate mass and volume. So now we look at specific gravity. What is specific gravity? The specific gravity of a substance is the ratio of the density of that substance to the density of water. So, if you are asked to calculate the specific gravity of any substance, you simply divide the density of that substance by the density of water. So for today's lecture, we have covered density calculations and we have also covered specific gravity. So this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I'm gonna see you in the next lecture.